In this video, I will show you how to prepare for the longest common prefix problem from LeetCode. With this problem in an interview, you are not tested for algorithms or data structures, but rather on ability to iterate arrays and catch common edge cases. Even though the core idea of the solution is simple, there are still multiple paths you can take and some core aspects to consider. First of all, let's discuss the core idea of the solution. In order to find the longest common prefix across multiple strings, at a minimum, we will need to check if this prefix can be found in each string, so we will need to check n first characters in each string, where n is the length of the prefix. Now we have two main routes. Either we could find a longest common prefix between two strings and then try to find out how much of this prefix we could find in other strings, which would result in this prefix shortening until we find the longest common prefix among all the strings in the list, or we can iterate each string by one character at a time until we find a mismatch in at least one string. I would prefer this approach as it doesn't require us to store any additional information and ensures that we are not checking more characters than we absolutely need. For example, if we would get a test case where all strings are the same except one, which would have only one character the same, with the first approach, we could iterate through all characters in all strings but one before figuring this out. But with the second approach, we would catch it on the second iteration, while comparing the second character of each string, which results making quite a lot less operations. While implementing one of those approaches, it is critical not to get out of bounds of the arrays. The strings can be of different lengths, and it is important to account for that during the iteration. If not addressed properly, your algorithm could try to compare a character in one string with a character which doesn't exist in another, if the second string is shorter than the first one. This could result in an exception or undefined behavior, dependent on the programming language you are using, as you would try to access memory outside of the data structure you were working with. Another edge case to keep in mind is not having a common prefix or a non-empty string at all. In that case, you need to return an empty string. It is important not to mix it up with returning a null. Depending on the syntax you use, your code could do both, so it is important to check and make sure that it behaves correctly. During a live interview, if it is not defined, it would be good to ask the interviewer how your program should behave in this case. This could also demonstrate your ability to define requirements and not assume them, which is a crucial skill for a software developer. Now, let's go and implement the solution in Python and C++. First, we will need to find the length of the shortest string in the list. We could do without it, but this will allow us to deal with out-of-bound cases more easily and efficiently. There are multiple ways to do that. We will iterate through the list and find the shortest one. Next, we will iterate through each position in the strings up to the length of the shortest string. In each iteration, we will iterate through each string in the list and check the character at that position against the character at that position in the first string. If at least one character is different, it means the longest common prefix is a substring up to this position. At that point, we don't need to go further. In order to output the answer, we substring a string from the beginning up to this point and return it. If the loop finishes without any mismatches, it means that the longest common prefix is of the length of the shortest string. So we cut a string of such length from the first one, as we don't know which one is the shortest, but all of them are the same up to this point. This should do the trick. The time complexity of a solution is O of n multiplied by m, where n is the number of strings in the list and m is the average length of a string, as in the worst case we would need to iterate through each character in each string. This would happen if they all are the same. Memory complexity is O of L, where L is the length of the longest common prefix, as in order to return the output, we need to define a new string with an answer. I hope the video was helpful and you found the explanation you were looking for. I wish you all the best in your learning. If you liked it, please like and subscribe for more content like this. If you have any questions, please leave them in the comments below. Thanks for watching and have a great day.